Hello everyone, welcome back to my YouTube channel again. Today I would like to show and share about how to create project for WinCC Explorer version 8.0, connect with PLC SIM of TIA Portal version 18. In this section, I will create pop-up skin by using VBScript for open pop-up. In the previous video, everyone already learned about how to create pop-up of WinCC Explorer version 8.0 by using the button. And in this video, I will use the VBScript to open the pop-up. So first, let's create the project of TIA Portal version 18 with me step by step. Let's go. Okay, so we'll create the new project. Pop-up VBScript. Okay, so we can go to project view. And I will add the hardware configuration of PLC S7-1500 for connect with PLC SIM. Okay. PLC SIM hardware. We will take some time for create the project. Okay, and then I will go to empty for security first because we no need to put some password to the PLC SIM. We don't need. I will add one more digital output module. Yes. And first, very important, we need to enable the access, permit access with port and get for connect with the HMI. Otherwise, we cannot link data. Yes. And for digital output, I can put the some text for this. Example, PAM1, PAM2, PAM3, PAM4, FAN1, motor 1, motor 2, motor 3. Okay, just example. So I will create only 12 motors. Next step, we can compile the project. Okay, and then we can create the data type, PLC data type. Yes. For easy to link with the block, data block, because we no need to create one by one. Example, for fan control for fan, right? We can create only one library. So we can say fan library. We have start, stop, run, overload. Yes. Fall, reset fall, or we can say clear. And we can create the data block by using this library. So we can say fan data block, or we can say fan db. Okay, so I will use fa1 and use this data block. Sorry, use this data type. So fan library. So I can drag for 4 fans. Okay. And then we can compile. So we will got the same as the library. Yes. So very fast for create the data block if we use the PLC data types. Next, I will create the data block, function block for control the fan. So we can say fan logic. Okay. We can create the data type the same as the PLC data type. Yes, I will copy and paste for easy to create. Yes. So clear, for run, it should be output, right? For it should be output also. For show fall on the HMI or SCADA. So fans logic. So I will stop fan, start fan, and fan running. Oh, sorry, I will create one more for relay output. Yes. Okay. And hold signal when I push button start. So this is stop button, start button, run, and also hold signal run. So when fan overload, I will send fault signal to trip the fan. So I will use set coil. So when fall, it will trip. Yes. And I will create one more output relay. So before we can start fan again, we need to reset overload, right? So I will use clear, clear, and then reset coil for reset the fall. Okay. So that's all for this logic. And then we can call it to use fan1 control. We can call this function block to use. Example of F1. F1 data we have start, stop, overload, clear, fall signal, run signal, and relay output to control the contactor or VSD. Okay. This is for file number 1, and we can copy, paste. For file number 2, we can use this fan library, yes, fan logic and F2. Also fan 2, we can use start, stop, run, overload. Actually, this is normally linked with the digital input, right? So in this video, I just example, so I don't have the actual digital input, so I will use this for simulation. Okay. So fall signal, clear, alarm. After overload, we would like to run again, so we need to clear first, and then fan number 2. Okay. For fan number 3, we do the same this step. Drag and drop F3, go to fans DB, start, stop, run, overload, clear alarm, fall, and fan number 3. Okay. The last one for fan number 4. We can do it the same. F4, go to FA4, so start, stop, run, overload, fall, clear and fan 4. Okay, so right now we got 4 fans for data block, and we already call it to use in main program. Next we will create the pump library. So pumps library, I have only start, start, stop, run. So only one more speed, real data type. So we will create the pump db. So we can say pump db. Okay, so I will create pu1 and use the data type that we already created, pump library. Here we got pump start, stop, run, and speed, right? Easy, very easy. So we can drag and drop 4 pumps. We can compile. So all pumps we got the same as the library that we already created. Next we can create a new function block for pump. So we can say pumps logic. Okay, then I will create more. We can copy from this, copy and then paste. Okay, for run and speed I will drag to output. Yes, and create one more for relay. Relay output, right? We can do the same this for easy to control. Data type is Boolean. Okay. And then we can say pumps logic control. So stop, start, output, and hold the signal. When I push button start, and when pump running, I will move speed, move some data to speed, right? So move value, I will move 1500 RPM to speed. Pump speed, right? 0.0 to speed. And when stop pump, when pump not running, I will move 0.0 to speed. Okay, so this one should be one more output for relay output, right? Run, stop, start, run, and then it should be run, and this should be not run. Okay, so we can compile and go to create the function for easy to combine. So this one should be pumps FC. Okay, so pump 1 control, and then I will use this pumps function block. So P1 should be P2, should be P3, this should be P4, yes, and we can use the pumps DB. I have PU1, yes, PU1 start, stop, run, speed, and this one for pump 1. For PU2, we can say start, stop, speed, run, and relay output, right? So pump 2, yes. And pump number 3, we can go to PU3, start, stop, run, speed, and also pump 3. Yes. For last one, we can say start, stop, run, speed, and relay output pump number 3. Okay. And don't forget call this function to main program. So I will call app pump fc to main program. Yes. So we can call fc pump fc to this. Yeah, finish. And next step we have a motor, right? So we can create the data type of motor. So we can say motors library. I have only start, stop, run, current, current is real data type. Okay, so I can copy and create the new data block for motors. So motors DB, we can say M1, and for the data I will use the motor DB. So motor library M1, M2, M3, M4. Yes, and we can compile the program. Yes, actually we need to optimize block. Yes, check and check the optimize block. Yes, okay. Okay. Next, I will create the motor logic of a function block. So I will create new function block. So we can say motor logic. I can paste. Yes, start, stop, run, current. For run and current, I will drag it to output. Yes. So logic control stop, start, run, lock hold the signal, and when run, when motor running, I will move 10M to current, and when motor was stopped, I will move 0.0 to current. Okay, so stop, start, run, and I will add one more for relay output. It's Boolean. Okay, so when motor running, I will move 10M to current, and when motor stop, I will move 0 to current. Actually, this input we can connect from the actual current of motor, but in this section I just simulation, so I will put some number for easy to understand. Okay, so next I will create one more FC for motors FC. Yes, so first motor 1 control. I will use the function block of motor. So M1, M2, M3, M4, okay. So for motor number 1, I can use the motor DB, start, stop, run, current, and relay output I will use motor 1, motor 2 start, stop, run, current, and relay output number 2, start, motor 3 stop, motor 3 run, motor 3 current, relay output of motor 3, for motor 4, start, stop, run, current, and motor 4. Okay, so we can call this function to main program. Yes, so I will call motor function to main program. Okay, actually for this function block we can also combine also. Yes, I will create for combine. This one for fan FC, right? Fan FC. Okay, and then I will go to this network. We can select and cut from this. So cut and then paste in fan. Okay. So I will call also fans FC to main program. So we can call fan. Yes. So finish. Next step, we need to compile the program and download to the PLC sim. So open PLC sim. Okay. So right now it detects one S7-1500. Yes. So we can download. And then we can load to the CPU. Okay, start the CPU. Let's see, right now the PLC is running. So next step, we need to create the WinCC project. So go to WinCC project. I'm using WinCC project version 8.0. No need to activate because we create the new project. Okay, I will create a new project. PLC S7-1500 SIM pop up. Okay, so first we can go create the picture. I can say main screen. Create one more for pop up lift and go to take management. I will create SIMATIC 1200 or 1500. Yes, create a new. So S7 1500. Here we can type the IP address 192.168.0.1. 192.168.0.1. PLC S7 1500 connection. Okay, and I will enable this main screen as picture, start picture. And then go to property window. I can use the title box border, maximize, minimize, or we can do full screen. To read all the text from TIA Portal to WinCC Explorer, we need to activate the WinCC Explorer first. So let me activate. Please button activate. Okay, and go to take management again. Okay, if so like this, it means that communication between WinCC Explorer and PLC SIM is working properly. So we can right click and then read all text from TIA Portal. So I will read from AS. So we have digital output, 12 digital output, and fan DB, we need to access for all fan. Let's see if we create the fan data type. You see, we will easier to create the data in WinCC Explorer. Yes. Okay. One more for pumps. Okay. One more for motors. Okay. So all data, make sure all data that we will use need to access by checking the block. So next we can create the pop-up library. Or we can rename the pop-up as motor fans pop-up library, because I need to create 3 pop-up library. First for use with for fans, second use with for motors, and third use with the for pumps. Okay. So I will adjust the geometry 250, 250, or 200, smaller than this. Yes. Okay, so for fan we have the data, right? We need to show start, stop, run, overload, fall, and clear alarm, right? So I will adjust this to be bigger than. Okay. So I have button start, have button stop, and have button clear. I will adjust geometry a little bit more. Yes, like this. Okay. And then fan, I will use the control Siemens HMI library. Should be shear and color red before when the fan is stopped. Okay, so this one should be stop, this one should be clear. Okay, so I will change the font size to be 24 bold and change the color to be blue, red, and this color. Okay, so before we can use, we need to configure this button. Yes, I will change the font color to be yellow or white. Okay, so I will configure this button. We will use this event, right? So focus on mouse, click. I will change bit to 1 as the point start, right? So underscore start, because I will use take prefix for control the fans by no need to create for pop-up. So I will create only one screen and then we can call the pop-up to use. Okay. When I release, I will reset to 0 as the underscore start, and stop is the same. So when I freeze, I will set to 1, stop, right? And when release, I will set to 0. And when motor fall, we need to run again. Then we need to clear alarm, right? Clear fall. So I will use 1 for clear fall. Sorry. Underscore clear, right? And when release, I will reset to 0. Okay. And for color of fan, I will change. When we start, we need to show. So I will use function, internal function, text, get tag bit, and choose the tag name, underscore run, right? So underscore run and use boolean, change color to be green when running, and change this one to be this, and we can save. To call this screen to use as pop-up, we can go to the main screen operation, open, then I can copy from this, yes, file number 1, file 1 control, we adjust font to be easy to see. I can adjust some color. Yes. Okay. So I will create the picture window for show the pop-up of these fans. Okay. And the window name you can rename as model picture. Model picture. And then we can set the property of this pop-up. So display I will use nose, sizeable, movable, title we need to put closable, adapt size. And for picture name we can double click here to choose the screen that we would like to use as pop-up. So I will use fan pop-up. Yes. And for the tag prefix, we need to put the tag of which motor or which fans that we would like to control. So we can put it as this. Tag management. We can put like this. Fan 1, right? So we can say fan DB FA1, yes, and this one should be deleted. Okay. So all data of fan 1 we can control from this pop-up. Okay. Then I will use the title, yeah, header. I can say fan 1 pop-up control. Yes, fan one pop-up control. And then in this animation, I will revise as this take. Fan one running, right? And we need to use the event object event to call this pop-up. So I will use event, and then when I click, I will use VB script action to call those pop-ups. So we can write it as set property by constant. I say part. We need to put the window, screen window, right? So this one I will use this first. Visible one. Okay, there is no error. And then we need to put the name of this window, right? So motor picture I copy to insert in this VB script. Okay, and then we can run the project for test. Okay, the default we don't get the pop-up, so when I click, the pop-up will appear, and then we can control. So we can go to the FC fan FC, right? Fan number 1. I can start, yes, stop, start, and I also can close the pop-up screen and open it again, yes, stop, start. So next we need to clear alarm or fall when we got fall, right? So we can configure this. Run it will be green, right? Not run it should be fall. So when the motor is fall, we cannot start, right? So let me test. I will put overload for fall. fan output is on. The logic is incorrect. So I need to check and change the logic again. When overload, it should be false. Okay. So this logic should be reset. So I will download the project to PLC Sim again. Okay, so that's correct. When motor fan is full, it will be tripped and cannot start. So we need to reset first. So I will put some signal for fall in the pop-up screen. So this normal is green. If we got fall, it will change to be this color. So function internal text get text when one fall, right? So we can test again. Okay, right now the fan was fall, right? If we try to start, we cannot start. I will release the button, the bit of fall from this logic, and let's see the status should be changed, right? Okay, I will try to clear. Yes, so the status is okay, and then we can continue to start fan. Yes, if it fall again, overload again, it will trip the fan, and then it will be cannot start. If we would like to start, we need to clear, and then we can start again. Okay, so we can copy this To apply for fan number 2, number 3 and number 4 also. So this one should be fan number 1, number 2, number 3, number 4, and I will use this window only one library, so I can duplicate, okay, and then I can change the property of window. So this one again the same. So this one should be FA2, fan 2 pop up. This should be 3. This one again the same. Number 3, fan 3. This one should be the same. Fan number 4, pop up number 4. And for the fan status, I will change to be fan 2, fan 3, fan 4, and also revise the script on VB script. This one no need to revise because we use only one picture, right? Okay. So let's test all those pop-up. Okay. Fan number 1 is running. Fan number 1 is running. Let me check the pop-up. This one should be we need to change, right? This picture 1. Change the script to be 1. This one to be 2. This one should be 3. Okay, then we can run again. Okay, fan number 2, fan number 1, fan number 3, fan number 4. We can move anywhere that we want. So we can try to control to PLC. this fan number 2, right? So I will open the pop-up again. Fan number 2, I can start. Yes, running, stop, start. When it got overload, it will be trip and show alarm. Yes. If you would like to run again, we need to clear. Not yet correct. Eh? Fan number 3, the same. Fan number 4. Yes. I will try to clear. Can clear. Why this one cannot clear? Fan number 2 cannot clear, right? Let me check the logic is correct. Go to take management. Fan number 2. Fan number 2 clear. Yes, I forgot check the take. So we will try again. Okay, we can clear right now. Then we can try to operation again. Yes, I can stop, start, 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 and start. Okay, you can stop, 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 and start all again. And then I will put all fan is overload. So fan number 1 trip, number 2 trip, number 3 trip, number 4 is trip. So it worked properly. Okay, and we can start again. We cannot start, we need to clear to be ready to start first. So start, 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 and start. Okay, so we can create only one library for screen, and then we can call it to use by using the take prefix. I hope everyone will understand about this concept. It's very fast to create the pop-up by using only one screen, and then we can pop up to use. So we can practice it for simulation. No need the hardware of PLC. Thank you so much for watching my video. If everyone have any question, please like, comment under my video. I will reply for everyone. So in this time, I would like to say thank you very much again and see you next video. Bye bye.